I'm Sean Godak and I teach AP Calculus with Eric Withers, who teaches AP Physics. We've been teaching together for about 7 or 8 years. I've been teaching the AP Calculus course for 10 years now. The whole goal is to actually prepare students for the AP Calculus and AP Physics exams, but also well beyond that to make sure that they are ready for college level, college-ready courses and entering either into Calculus 1 or Calculus 2 at the college level. In AP Calculus and AP Physics, we do a lot of activities together that describe change and motion. One of the reasons we have the two courses together, Calculus and Physics, is Calculus is the study of change. But one of the things that we also do in Calculus is to discuss maximization, minimization of objects, finding maximums and minimums of functions, and optimization. One of the activities a classic activity that we do in Calculus is box optimization, where you take a single sheet of paper and the idea is to decide how far to cut out corners in a box or in a sheet of paper so that you can fold it up to maximize the volume inside of the box. We go through the calculations, we make all of the measurements on the paper before, so the very last thing we do is actually make a cut into the paper. We do this with a lot of different other models, especially on paper we calculate things about maximizing the volume of a soda can in terms of minimizing the amount of material that's used. So in a manufacturing standpoint, manufacturers want to minimize the cost of the actual product itself, but try to maximize the amount of space inside of there. So that's one activity that we do in class. Other things we do are we build models to represent some of the things that we do in class. We calculate different volumes of complex shapes beyond volumes of cones and spheres and rectangular figures. With calculus, you can actually calculate volumes of functions that have very odd shapes and odd curvatures and silhouettes. So one of the first things we do is create models that actually represent some of the odd shapes that we're trying to describe, and then we go through the mechanics of the equations and the calculations to actually calculate those volumes themselves.